Usually you cross 100.
People are exactly on time, you are telling, huh?
Not really. I'm saying they're usually 5-10 minutes late.
So that's usual as Indians.
And the other thing is virtual meetings, the attendance always, there's a huge gap between registrations and actual attendance.
Okay.
Good morning, Alamelu.
Good morning, Alamelu. Yeah.
Welcome.
Hello, Alamelu. Welcome.
Good morning, Madam Alamelu.
Good morning, Alamelu.
I cannot unmute.
Good morning, Alamelu. She will only respond
Good
to
morning,
me.
good morning, good morning. Yeah. I can only
Morning, Alamelu.
behave as the boss says.
So,
She will only respond to me.
Morning, Mj Rahman sir. எப்படி இருக்கீங்க?
நல்லா இருக்கேங்க மேடம்.
Good.
We are 4 minutes past now.
எல்லாம் நேர்ல நாங்க பார்க்க முடியலையேன்னு தான் ரொம்ப வருத்தமா இருக்கு.
Really, last year this time we made a trip and it was very pleasant visiting you.
Yes, madam.
Yeah.
The meeting the persons always give the energy.
It is a different ball game altogether. It is more interesting than this Zoom and too much of Zoom meetings.
So wouldn't we start PM
Yeah.
with your permission?
Yeah.
We are 5 minutes past the time.
Should we start at PM?
Yeah, no problem. We can.
Okay. So good morning, everybody, and thank you all for taking time to attend this PALS Cash and Shares. We will start the session with a welcome address by our chairman, Palkat Mohan. Thank you.
Thank you very much, Bharani. Good morning to all. Respected faculty from PALS partner colleges, our distinguished panel members from academia and industry, dear students and IIT alumni champions from PALS. A very hearty welcome to our PALS Cares and Shares event on Industry 4.0. Industry 4.0 has been defined as the current trend in automation and data exchange in manufacturing technologies. The key words are automation, data exchange, and manufacturing technologies. Besides this, we also hear terminologies like artificial intelligence, data sciences, robotics, and so on and so forth. Now, these areas cover the total gamut of core and conventional engineering, as well as IT and digital technologies. Why I'm saying this is because students can no longer be complacent by hiding within the cocoon of their core field of specialization. We very often hear students saying that I'm a mechanical engineer. I don't think I need to attend this session, which is really related to electronics or communication or so on and so forth. But looking at Industry 4.0, a mechanical engineer, for example, must have a broad idea about IT-related fields. In the same manner, an engineer who is specializing in IT and communication also needs to have a broad knowledge of core and conventional engineering. Now, management and faculty of colleges face the challenge of convincing their students to embrace broad-based education. Also, how do they present Industry 4.0 to their students as a comprehensive package? These are the challenges faced by management and faculty of our colleges. We also have industry who face the challenge of recruiting the right talent with the optimum mix of knowledge and skills. There is an industry-academia gap which needs to be addressed. It is in this context that our PALS Cares and Shares session today has its relevance. PALS Cares and Shares is a new series of PALS events introduced during academic year 2020-21. In virtual format, wherein we involve experts from academia and industry to address typical problems and challenges faced by our partner colleges, with a bottom line of what PALS can do to catalyze the process. It is with great pleasure that we present before you a very distinguished panel of speakers who will address issues related to the industry-academia gap existing in the field of Industry 4.0 and how a collaborative effort can help to bring us closer to a solution. Industry 4.0 is also very relevant in the PALS context, as our theme for academic session 2021-22 will seek to address the industry-academia gap and add value to engineering education by making our events more and more industry-centric. So dear audience, please enjoy this session, and I hand you over to the MC to take this program further. Thank you very much.
Thank you, PVM. As PVM mentioned, we have a panel of eminent speakers, both from the industry as well as the industry academia. I request CM Chandrasekhar to introduce the panel. Thank you.
Thank you, Barani. Again, good morning to all who assembled here. It's an honor given to me to introduce the panel for this session. Let me start with academic people first, and in that, a lady comes first, always, right? So, Mrunamai is the Deputy Director of Center for E-Learning and Industry 4.0, Vishwakarma University in Pune. She has masters in electrical engineering, and she is teaching interdisciplinary subjects to the engineering students. She also has an advanced diploma in Japanese language. Industry 4.0 is one of our areas of interest. We are very honored to have you on this panel, Mrunamai. Thank you.
Good morning, all.
Yeah. Let me move on to a very senior academician in the panel, Professor Kuku Swami. He is well known for his academic administrative ability. He has over 42 years of experience in academic, which means teaching, research, and administration. He was responsible for establishing the Department of Computer Science at Pondicherry Engineering College and also at Pondicherry University as the first professor and head of the Computer Science Department. In recognition of his excellent service, he was appointed as the first dean of Ramanujan School of Mathematics and Computer Science, and then as a director of educational innovations and rural reconstructions. As Pro-Vice Chancellor of Pondicherry University. At present, he is the Executive Director of Vivekananda Educational Institution for Women in Trishangur. We are very happy to have you, Professor Swami. Thank you for taking time.
Good morning. Thank you. Thank you.
Next, we go on to another senior academician, Dr. Mj Rahman, who has more than 30 years of teaching experience. He has completed BE Mechanical from CIT Coimbatore and ME Production Engineering from GCT Coimbatore. He degree from Anna University, Chennai in 2009. His areas of research include metals joining, metal casting, rapid prototyping. 8 research scholars have completed their PhD under his supervision. He has published 30 papers in peer-reviewed international and national journals. Currently, he is working as Professor of Mechanical Engineering and Principal of LRL College of Engineering and Technology, Erode. Thank you for taking your time.
Thank you, sir. Good morning to all.
Much. Nice to see you here. Next, we have the industry panel, which will start in alphabetical order. Atul Marathe has over 35 years of experience in software services and software product development industry. Atul did his graduation from IIT Bombay in 1982 and master's in industrial engineering from NIT Mumbai. 1984, he is interested in creating a roadmap for the Industry 4.0 journey in line with how software industry in India improves quality and reliability going through maturity model. We are good to see you, Atul, again here this morning.
Thank you, sir.
Next, we move on to Nitin Nair, who works for Siemens in Digital Enterprise and Digital Services Division. He has more than 22 years in the fields of factory automation, machine automation. Great passion for Industry 4.0 and industry-related digitization concepts. He has defined business strategy for growth from the trends of digital manufacturing, electric vehicles, and specific market segments. It's a great area, Nitin. We look forward to hearing from you in this panel. Welcome.
Good morning.
Next, we move on to Rajesh Roy. He's an associate partner at IBM GBS with 20 years of deep business and technology consulting experience in supply chain domain. He has a proven track record of designing and delivering IT-enabled global transformation programs for major corporations. An articulate presenter with strong interpersonal skills, published 3 books from McGraw-Hill publication, authored 65 articles in international journals, and an honorary member of CII Logistics Council, Epics India Chapter, and Star Society. Wow, that's quite a lot, Rajesh, and nice to have you here. Pleased to have you here. And the panelists have been introduced, and now I move on to moderator. I'll keep it brief. We have today Narayana Swami. He's known as Nanu. He did his mechanical from IIT Madras and MS on entrepreneurship from IIT Madras, and he went on to doing so many things. You will experience him today. He doesn't need any introduction. He's a very, very active PALS champion, and he has also got a lab, a mini lab. We can call it as a mini industry 4.0 lab in Madurai. Encouraging people to come and experience what he has in the lab. And now we are pleased to have you here as a moderator for the panel, and I hand it back to Bharani to run this for further after this brief introduction of the panelists.
Thank you, CNC.
Thank you, CNC. And now I request Nano to take over the stage, and Nano, it's all yours. Thank you.
Okay, thank you all. So actually, instead of starting this session the traditional way with a PowerPoint presentation, I want to kind of give you a hands-on experience of what Industry 4.0 is and what the whole buzz is about. So what I'm going to first do is, in the screen behind me, you see a little light bulb. So I'm going to use my little phone here, turn the light bulb on, okay? So the concept of, the traditional concept of a physical switch. Let's stop. Okay. Can you see my screen too? Oops.
It's getting started.
Not yet, Mr. Nanu.
Yeah.
Okay, I actually want to just see my video a little bit. If you can watch my
video.
We are
seeing your screen now, yeah.
Okay. So if you, behind my head, I have like a little light bulb, and the concept of the switch has is gone away. As far as a lot of equipment goes with the Industry 4.0 age, the concept of this physical mechanical switch is disappearing. You can control things from anywhere, thanks to lots of different things that have played a role in this. So for example, the switch, the light that you see behind me, let's assume it's like in some industry somewhere. So, maybe the machine is down, and, it shows red color, and people working in the factory, they kind of realize the machine is down. And maybe after some time, maybe somebody goes there and starts repairing it. And then you have a different color code, maybe blue, says people are working on the machine, okay? And right now I'm controlling the colors based on an application that I have running on my machine, on my phone. And maybe after some time, it becomes green, okay, which means the machine is repaired. This kind of paradigm where you can control a bulb, a motor, a robot, anything of that kind, is changing the way that industries do things. Earlier we used to have somebody to go turn the lights on in the morning, when there's nobody, turn the lights off. In this particular case, you can save so much energy just by, if there's nobody in the factory, you could turn the lights on, lights off by itself. So this simple paradigm where you don't have a switch, the physical switch for doing things, is changing the way industries are reorganizing their assets and their profiles and their operations. So since I have exactly about 8 minutes left. This little device that you see, there are lots of these small little devices that are coming out of the market, where you can do, this is like from Intel. It's a small Intel Movidius chip, which is basically an artificial intelligence machine, which can collect data from your factory floor, from home, from anywhere, from the environment, assemble it and send it over to a central processing unit, which can turn on lights, turn on motors, turn on air conditioning, turn on all kinds of different things. So we have lots of new such devices coming onto the market. So again, what you see here on the screen is like a small micro computer. It has the same power as the desktop as most of you have right now, but it fits in the palm of my hand. And this thing is basically one of the other agents that's changing the way industries and other businesses are rapidly changing in the way information is collected. And last but not the least, I have to kind of talk about this third device, which I think will ring a bell with Nitin. So this is like the Siemens microcontroller. Okay, so this is one of the key devices that's changing the way in which industries are picking up data and automating the systems. So this little machine, I would call this little box, which is live right now. It's, you could get it for anywhere from 5 to 15 to 25,000 rupees, and it's basically an industrialized computer. It has everything that you want except for the screen and the keyboard. But the most important thing that is revolutionizing the Industry 4.0 is this port here, which is the internet port. So you can control machines with this. You can read things. You can read sensor data. For example, here I do have a few switches down here, which could be different kinds of things that are read from sensors. So if you look closely, as these switches change, you can see the outputs. I could kind of control motors based on the output of different things. Okay, so this microcontroller is been there for a long time, but the key thing that's changed this the paradigm and brought in industrial IoT and the 4.0 paradigm is the internet port, the network port that takes this data and makes it available to everybody. So with that, let me go on to my presentation here. So the birth of Industry 4.0 has occurred because of interconnectivity. You have a lot of IoT things, you have access to real-time data, and there are some terms, called the cyber physical systems, which basically include the integration of computation, networking, and physical processes. What that means is you can pick up data from the environment, from sensors. You have like good networking mechanisms to take the data, from wherever it is and compute it, process it and send it over to other places. So this is making this Industry 4.0 is having a vast impact, not only on industry, but also in areas like farming, so farmers in remote areas, they could turn on their water pumps, from wherever they are, check soil conditions, so many other different things. Okay, so since my goal is just to lay a foundation for understanding what the panelists are going to talk about, I just have 2 slides, which is the first one and this one. So from Industry 4.0, what we get is the lowest one here is we can get information on what is happening. What, is my motor on? Is my factory up and running? How many widgets are widgets being produced? Then you can also get a count of how many widgets are, how many footballs have been produced, or how many water pumps have been created, what has happened. And then you can also get information about why, maybe the production went down, or maybe why certain things were not working well, or maybe why certain things happen very well. And the last but not the least is once you get information about all what's happening, you can kind of figure out what is going to happen, which is more like the application of AI, which is basically those little, these little devices come into play. They take the data and analyze it on the edge and send the data over out. So predictive analysis, diagnostic analysis, descriptive analysis, and operational reporting are 4 key features that lay the foundation for 4.0. So the areas where these can be applied to, we could optimize logistics and supply chains, autonomous equipment and vehicles. You could build your own autonomous vehicles and equipment using the technology. Robots are playing a big role in it. And as one of our panelists is an expert on additive manufacturing, where you kind of, you can build rocket engines by, you can actually theoretically, practically build rocket engines using additive manufacturing. So there's a company in IIT Madras which does that. And you can Google for that. They do have new kinds of 3D printing capabilities where you don't need to cut metal. You can basically build engines, rocket engines. And we have Internet of Things and the cloud. And I think that is like a summary of what I want to talk about Industry 4.0. I think we're going to go start the panel discussion so that we get insights from the experts that we have brought together from all around the country. And one more thing which I wanted to kind of touch upon is there is a lot of work to be done to get students and staff in colleges onto Industry 4.0, which is like a wide topic. It's not like a physics or a chemistry, but it's more like an amalgamation of about, I would say, at least 10 to 15 different subjects. And what you see on the screen is like some new equipment which people have started making for creating labs, for integrating all these kinds of technologies. How do you make things work? So there is a need for people to even create equipment that can be used in colleges for teaching people Industry 4.0, since it's like a whole mix of different kinds of subjects. So with that introduction, I'd like to welcome the panel, and each question that I ask has a budgeted time of 4 minutes. So I'd like to mix the industry team and the education team. I'll start with a question to the industry team. And then after that's done, I'll go to the education team and then keep switching to and fro. And I'd like to first ask Dr. Atul Marathe a little about what his feeling is about what is the buzz around Industry 4.0. How real is it? And from his perspective, the industry team's perspective, what are the significant things that come to mind around Industry 4.0? It's a very general question, so I'd love to have your insights, Dr.
Sure. Thanks a lot, Nanu Swami. I was looking at the slide that you're showing right now about a panel discussion, and I don't think we'll be too far from a time when the panel discussion will really be a set of electronic panels which talk to each other and not people talking to each other. So we will soon come to that stage where if you have a panel discussion, it will be robotics and electronic panels that talk to each other. Now, whether Industry 4.0 is a myth or how much it has penetrated in the industry and in the countries, if you ask me, I think the proof is what we saw in your presentation earlier, that if a college faculty can demonstrate the use of IoT devices and electronic panels and lights that switch on and off, that's the last stage, I would say, where it has to reach. Because if Siemens person Nitin Nair says something that we do this way, or if Rajesh says from IBM that we do this way, I have to take it with a pinch of salt, because sometimes they do some demonstrations which are not so really reach to all the masses. But if it goes to colleges and you can demonstrate it, then obviously it's already there. I will try to take a slightly different approach or a different perspective to Industry 4.0 than what you have covered right now. That is from the need point of view, or why this is getting driven right now. Uh, I find that there are two ways to look at it. One is definitely the technologies that are progressing, and you have given a lot of examples of some of those technologies which have progressed, and they definitely contribute a lot to automation and data transfer. And obviously you talked of the internet port, which is the most critical element of any device today, so that it's not only locally connected, but it's almost connected to the entire world. And every single piece or every device is like talking to the world if required. So that is the technology part of it. It is not a hype, because the simple answer is it doesn't come on the Gartner hype cycle. If you look at the Gartner hype cycle, where technologies are progressing and coming into real life, Industry 4.0 is not one of them, because it's not one technology. It is a mixture of several technologies that are coming together, and people are trying to exploit these technologies for their advantage in manufacturing. So we have to look at it from a demand point of view. I would say let's see why Industry 4.0 is suddenly picking up as a buzzword now. It's not that it was a need felt somewhere, but it was a collection of technology, I would say, which make certain dreams or certain wishes of customers possible. If we look at the old age, you'll realize that a lot of things were handmade, and in Industry 1.0, 2.0, everything was customized because everything had to be handmade. You can't have mass production. Then we started with industrialization and mass production. And if you look at the 19th century or the 20th century also, we find that mass manufacturing has given us a lot of benefits. But definitely mass manufacturing, standardization doesn't help human beings, because they like something to be unique about, they like something which is special for them. And that crave has suddenly gone down because of economic reasons, that no, if you buy something which is standard, it is very easy and cheap. But if you want something completely customized, that is going to be quite costly for you. That was the learning we had till now. But now people are realizing that why not have a combination of both? Can I really go for customized products at a low price? So the new mantra is it should be cheaper, faster, and better all together, not compromising between one for the other. So that's one important thing we are looking at now. And from mass manufacturing, we are now turning to mass customization, so that can we customize each and every product and service that we are offering to the customers, and can it be made faster and cheaper and better? So that's the whole aim of it. And I think that would be a good start for it. And let's see what other panelists have to say about it in terms of technology.
Excellent timing. Atul, I don't know whether you timed it right. Like, it was perfect, and it was a great introduction to the whole thing. Wonderful. So thank you for that. We're going to come back to you with something a little bit later. But let me go to the educationalist team. And as CNC said, we'd like to have the opinions of Mrs. Mrunmayee Ranade first. I'd like to ask her the question on what are the challenges and interventions and innovations that are required to bring curriculum to colleges, and her perspective on the Industry 4.0 and how to kind of bridge the gap between academia and the industry. Thank you.
Thank you, sir. I would like to first thank organizers for giving me a chance to express my views because I'm quite junior to all other panelists. But I'm happy to represent Vishwakarma University and in specifically Center for Industry 4.0, due to which I am very much closely associated with certain practices which are taking place in the academia due to this disruptive Industry 4.0 technologies. I would like to even share that we are founder members of the Center for C4I4 labs, which are four all over the India, and which is the Ministry of Heavy Industry initiative. So due to which, looking at this as a chance to accelerate the process, obviously COVID also facilitated us a lot, that the electronic e-learning is much faster and much accelerated within the last few months, which we wouldn't have achieved maybe within a year or two. uh, about the innovations, I'll come first, that maybe we have, instead of traditional learning, we have to now think about the um, competencies based learning, that we have to develop the skills of student, and we have to make them more learning oriented than the normal way of teaching which we adopt. Like teachers will be facilitators more, and they will hold hand of the student and guide them to perceive their own maybe viewpoints or thinkings. Obviously the industry 4.0 technologies like AR VR or 3D printing or data analytics, we can incorporate much if we go for this type of learning, and that is student centric or student oriented, or specialized learning for from one to one student point of view. Of course, for all these things, teachers have to adopt themselves a lot, because we have a way of learning for years, which we have to uh, change a lot. Of course, different pedagogies people are adopting, like video streaming, flipped classroom, are much adopted versions of new era or new style of learning. Uh, of course, for this one more major thing which is required is a smart and fast LMS, learning management system. Because if I go for open curriculum, like student based different types of maybe assignments or works expected from them, then in the mass learning which we have normally the case in India, it is very difficult to judge their performances and uh, compare their expertise in or qualifications qualities which they develop. One more important thing which we have to which we have to face in a near future, obviously, will be a credit based system. Like not in a university, I'll not continue with the all courses, but maybe online and all with different all over India or all over world, we will go on adopting and accumulating credits based on certain learning mechanisms, and the student will be offered or conferred degree based on this entire learning stream, what he or she has perceived. About the interventions, I'll come now, that basically to start with, we can adopt a small two courses, of course, interdisciplinary courses, which is very much must nowadays. I can't say that I am a mechanical engineer or I am a computer engineer, so this is not my cup of tea. I have to think about multidisciplinary and different approaches and take into consideration all these things. We can have two courses. One will be based on totally theoretical orientation, that give the idea about the different technologies and how they work for getting insight for industry 4.0. And the second course will be totally different, not exactly the theoretical kind of, but it will be a practical application of this, because we are talking about many a times superficially different technologies. Of course, yes, big industries, it's possible and feasible to adopt them because their capacities are larger. But for MSMEs, it's quite challenging to go for such such entire disruption of the systems. So we can think upon how and where they can become smarter by maybe stepwise spending money, and there will be a better perspective. Even students should get a chance to actually do the internships or projects with the small scale industries, so that they can even understand the pain, which saying something on paper and actually implementing needs a lot. There is a huge gap, and normally students as a student don't understand it well, because they think that after this point comes, but there are different challenges in between which they have to face and they have to overcome, where there is a possibility that they will give up. This generation is quite habitual to this type of giving up nature, right? So
Yeah,
we have to
I think so.
accommodate the students accordingly.
Yeah, I
So
think it's,
that's all from my side.
I think it's good points, you know, bringing practical and theoretical, and a lot of good input from you. Thank you, Mrs. Mrinmai. We'll come back to you in a little bit. I'd like to kind of switch again to the industry team. I'd like to have in some input from Nitin and his perspective on what's rational behind introducing Industry 4.0, and any specific examples from the business perspective, and any interesting perspective from him, being you know, working with one of the global giants in Industry 4.0. I'd love to hear your thoughts.
Thank you, Nano. So let me bring in the user's perspective into the discussion. And because I work very closely with a lot of users, both big, medium, small, and MSMEs. So I keep discussing a lot of challenges with the industry on Industry 4.0 and what are their perspectives. So from their perspectives, as you made a nice demonstration at the beginning of switching off the lights, saving energy. Well, for the industry, for the manufacturing MSMEs, they are under constant cost pressure. So anything that can be done to help them reduce cost is welcome. And they are looking for such digital interventions to help them. And that's what we need to, or that's what I would request the students in the academia to understand the motivation of the manufacturing industry, the MSMEs, to do this. Why do they want to do this? Yeah, they want to do this because they want to reduce their rejections in quality. They want to improve their quality. They want to improve their first pass yield coming out of the factory. They want to increase production from the same line. They want to do more from the same line with less energy, with less resources. And a wonderful example of this, which I was also discussing with Atul, is in Germany, there is a wonderful program called the Dual VET program, where the students in the last 6 months or 10 months work with a small industry, MSME or a mid-sized company, and they implement a project on the field. Now, this is a benefit for both, because for the MSME, the kind of costs stay down and they are able to realize the benefits. And for the students, it's a real project on which they work together with the industry and develop something which is relevant for production and relevant for manufacturing. So it is this kind of programs which are relevant for our industry is what we need to also focus on. And that was the user's perspective that I wanted to bring to the table. Because you see, from the user, the guy who's going to finally live with this Industry 4.0, what is he thinking? He's thinking, how will this benefit me? Second, somebody from academia, somebody from Siemens may come and implement this for me, but after it is running, will I be able to run it? Will my people be able to run it? Yeah. So it's not only about the new people entering the industry or skill of the new students entering the industry. It is also, there is a big challenge out there also about reskilling. And the third thing is we also need to look at moving from an automation to autonomy. You showed the example of the light and turned the colors blue and green depending on the situations, where it was you who was making the decision to change the colors, and then it could be a microcontroller that would be an automation. But think about it, if there was a vision system and an AI algorithm behind it making the decision that now, okay, the panel doors are closed, the people are gone, the light on the machine has turned from red to green, therefore the maintenance is over. Yeah? And this is what is going to be driving the autonomy instead of the automation is what we should focus on. That makes it simpler for the user to keep running and realizing the benefits of the system. And it also makes the whole process of adoption of the technologies much easier for the user, because at the end, the user is the king. When he uses it, everyone works together.
Excellent. I think that's a great introduction to what the user's perspective is. Thank you, Mr. Nitin, and thank you for joining us amidst your busy schedule. I'd like to kind of switch focus to the education team again. I'd like to ask Dr. Mj Rahman, who's kind of in the midst of this Industry 4.0. So he lives in a part of the world where the industry, which is like, Coimbatore and all the textile, the textile kingdom of India, has so much automation. So he's in the kind of midst, very close to this area, and he is the right person to give us a perspective on what kind of education is required. Since he's very close to the industry, I'd like to have his perspective on what kind of education is required for the students to be ready for Industry 4.0.
Good morning,
Dr.
sir.
Mj Rahman. Good morning.
Good morning to all. I'm happy to participate in this panel discussions. So as we are all discussing about the Industry 4.0, so whatever the technology is developing and we are making ready for the students, but we should not forget the fundamentals. The major focus, now why they are coming for the engineering education. Primarily, if you see that, they need a job. So the job perspective is almost 70 to 80% of the engineering graduates are absorbed by IT and IT-enabled services companies. The rest of the 20% only, they are going for the core industries and other things. But in that case, as a education, there is an institution, we are having the dilemma where to develop the students, because daily we are getting a lot of technologies, and I have to make the student ready for the market or in the industry perspective. So it is very difficult to see only in one area. So that is why if you take that 20, 21, 22, 23, 24, the 4-year students are there. So when they are coming out, so what kind of technology is having? So we are unable to predict. So that is why from the past, if you see that, the student should have the foundation and fundamentals in their own area, core area. It may be the mechanical engineering or civil engineering or electrical or electronics, computer science. If we taught fundamentals very well, then very well easily they can absorb the technology, because it is very easy now. A lot of massive open online courses are there. So they are very much easily grasping and they are getting the new technology. So I do agree We have been taught for the years together about the mass production and the customization, everything. So automation play a vital role, but even then, the student should be taught in the fundamentals. Previously, the mechanical engineering, civil engineering. Now, there is a shift. So we called as interdisciplinary. That is why the mechatronics came, and the information technology, they formed computer science, and there is a communication. But now, no longer the interdisciplinary. Now, the industry need the multidisciplinary persons. So a civil engineer must know the fundamentals of the civil. At the same time, he should know about the digital technology. So how well the digital technology can be applied in their field in order to improve the quality, at the same time reduce the cost, at the same time reduce the time, because the time factor is the major thing. So as a mechanical engineer, he should apply everything. As a mechanical engineer, you should visualize the product. So everything is going for the digital manufacturing. As Nanu told about the rapid prototyping, it was developed in the year 1988, already 3 decades over, but still we could see only a fewer machines are available. And the technologies are there, but it is very difficult to manufacture all the goods. Still, we are going for the conventional methods. So in the same way, as an electrical engineer, we have to see that the service industry also, because he has to build a power, there is a power plant, and he has to give the power and other areas. So in that way, the electronics industries. So already a lot of electronic goods and the automobile components are having the flexible automation system and the robotics automation. So everything is there, but still it is not in a full-fledged. We hope the next few down the year, 5 years, we need this kind of the technologies. That is why we are teaching the students not only the fundamentals, at the same time we are giving a blend of the education on the digital platforms. From the first year onwards, they are studying about the coding principles, and then the electronic component and everything. So majorly, whatever may be the industry, 3 things are very much important for the engineers: the designing of any product or process or whatever may be, then the implementing everything, then we have to maintaining everything. So for these 3 sectors, so they need the wide area of their own specialization. At the same time, they need the latest technology. So in that perspective only, we are modifying the curriculum with the elective subjects, the open elective, and the core principles. And we have been constantly focusing on the students, because when they come out by 2022 or 23 or 24, so they have to know about the latest, the nuances of the technologies. Thank you.
Thank you so much, Dr. Mj Rahman. I think it's the key takeaway, from all this is we need, even civil engineers educated on digital technologies, and the output you'd get from such an initiative would be kind of tremendous, because we see all the equipment they use, for surveys and things like that. They're basically little computers with lasers and everything else, and they could do wonders if they are able to, if we are able to teach all disciplines a little bit of digital technologies, which I think is very important. Thank you so much for your input, Dr. Mj Rahman. I'd like to kind of switch roles a little bit and go on to talking about what kind of job opportunities exist for aspiring students. I'd like to ask about this, and since he's been working with lots of clients implementing industry solutions, which we'll come to a little bit later, I'd like to get his perspective first on, from his vantage point, what kind of job opportunities exist for aspiring Industry 4.0 engineers. Dr. Rajesh. Rajesh?
Thanks. Hi, can all of you hear me?
Yes.
So thanks everyone first for giving me the opportunity to speak in this session, and I think a lot of very relevant points are already covered by different speakers. So I will talk more from my perspective and what I see in our company, what it does. Like someone told earlier very rightly, 80 to 85% of engineering professionals today are recruited in IT organizations. I'm not going to comment whether it is good or bad, but that's how it is happening in the job market for last 7 8 years. And I will tell that I will talk that there are two kinds of jobs which you can typically see. One is a kind of job which are kind of people whom we recruit who are specialists or who are supposed to work as specialists in certain industry 4.0 domain. So these are like specialists in sensors, they are specialists in embedded systems, they are specialists in industrial automation, they are specialists in additive manufacturing, they are specialists in robotics, they are specialists in industrial internet of things, those kind of people. Those are specialists. So for them, especially they were recruited from institutions who offer specializations on that. Like some of the IITs offer specialization on robotics. Some of the other institutions are there who are offering specialization courses on embedded systems. So that's one part who are specialists and who are supposed to work in projects which needs that kind of specialization. The second kind of job opportunity which happens in Industry 4.0 is a little bit, I should tell generalists. So, and I will talk about 5 categories. That's how it is organized in in IBM and many of the IT companies. One category, what we call as business transformation specialists. So business transformation specialists are those kind of people who essentially can go to a company and find out, understanding the company's business, understanding the company's current shop floor infrastructure and IT infrastructure, what kind of Industry 4.0 technology can make a difference for them and can do a value add for them. They can quickly do a cost benefit analysis and tell that, okay, this can bring you this kind of benefits. These are the kind of business KPIs where you can have a positive impact if you have an Industry 4.0 technology. These are the 2 technologies which can be used in your setup, which will give you some immediate benefit. And last is, these are the kind of use cases where I think Industry 4.0 will bring benefit for you. It can be, say, in your maintenance. If you do a predictive maintenance, probably your uptime of the equipments will go up by 10%, and that means this much amount of money benefit for you, and this much amount is the cost. Now let me tell you, business transformation specialists typically doesn't come from an engineering college directly, because this is something which where you need experience. I personally do a lot of this kind of work, and here you need to do some in Industry 4.0 projects, and there typically you need a T-shaped professional. So T-shaped professional means, if you look at the horizontal side of the T, where they understand different verticals of Industry 4.0 well, and then their vertical is what I call as the the vertical side of T, but they are specialists in certain areas. So in the sense that we also want business transformation specialists not to be too generalist. They should know everything, but they also should have a specialization in certain things. Like someone is very specialized in AI, but he plays also the business transformation specialist role. So that's one kind of job opportunity, typically for experienced guys. Second, what we also call as industry specialists. Industry specialists are someone who knows that industry very well. Like manufacturing setup in a semiconductor industry is very, very different from a shop floor of an automotive industry, and that is again very different from a shop floor of a petrochemical industry. And these are the kind of people who knows their factories and shop floor and their factory operations and process control equipments like the SCADAs and PLCs, what is used in that shop floor very well. And that's why they and they also understand Industry 4.0 in a broad way. and can figure out for their industry how this will work. Many a time we get this industry specialist from the industry itself, like we join a project and then we find that there are two guys in the client organization who are extremely good in their manufacturing, understanding their manufacturing setup, understanding their machines, understanding how the machines create data, etc., etc. And we bring them in our project as industry specialists. So that's the second kind of role which I will tell. And that is also a kind of people whom we recruit in the market. Third kind of people whom we recruit, what we call as solution architect. So these solution architects a little bit stronger on the technology part of the industry 4.0. So they know a variety of technologies well, like, like a lot of messaging technologies like Kafka, RabbitMQ, Webseries technologies, the devices protocols, the middleware, the cloud technologies, different types of field gateways what we have, how to do the data management, etc. But they are not, again, very, very deep in one of them. But where they're good is they know that how these different building blocks can be put together so that we can finally deliver the solution. Because in solution is not about one technology. Typically in solution need to bring different technologies together to make it happen. And these are, again, I will tell little bit, you need people who had done this before, little bit experienced people. Probably an engineering college graduate, once you do 3-4 industry project, probably he will get into as an industry 4.0 solution architect kind of role. Fourth, becoming quite important, is platform specialist, like, the people who are specialized in particular platform in IoT, like say platform from Microsoft, Amazon, Google, etc. These are also important because a lot of industry platforms are decided kind of solution. And the fifth, I know that I'm just probably running over time, is what I call as industry 4.0 developers. They're typically programmers who know a lot of programming skills of industry 4.0. Like, this needs specialized programming skill in embedded programming like PHPOC. You need IoT developers. You need people who have JavaScript knowledge, who can do programming, etc. So that's the typically developers. So that's in terms of the job opportunities on a high level. What I see is there in industry 4.0 currently.
Thank you. Thank you, Rajesh. I think that was good. And I think you taking the extra time was beneficial to talk about all these different roles. So thank you so much. So we do have business transformation specialists needed. We have solution architects needed. We have platform specialists needed, and we have developers needed. And also there was many other categories that I guess you haven't touched. So I'd like to again switch to Dr. Kupu from the educational team. If you can tell us a little bit about how's the demand from students for Industry 4.0 skills related courses. If you could give us some input from your perspective, that would be excellent. Dr. Kupu.
Okay, thank you, Mr. Swami. Good morning to my co-panelist and everybody who is just listening. Well, both the industrial group and also the educationist, they have talked all about the various aspects of the requirements of Industry 4.0, particularly with regard to the manpower requirement and also the state of art of the 4.0. Now, I have been given the task of telling how is the demand of this Industry 4.0 courses by the student community. Before I get into that, I would like to just say a few words of what we have been doing all along since our education system has started in a traditional way, the conventional method, and what is that we are expecting that should happen today. See, in the traditional education system, we have been imparting knowledge to the students, and of course, only the information transfer has happened. And of course, we have dumped a huge amount of information transfer to the student community. And later, we try to develop skills amongst them. But what has happened when you look back the last 50 years of skill training, today all those skills are probably 80% of the skills that we have equipped with the human resource have gone, waste, or rather got replaced by the machines today, because people talked about autonomous systems. And of course, it's not an automation. It's today we are talking of autonomous system, and we are talking of intelligent products, intelligent factories, and then even the assets, we are talking of intelligent asset. I think rightly Mr. Nanu Swami has demonstrated with all this intelligent gadgets at home. Really, it is quite interesting to look at it. But when I just see how the student looks at the today's curriculum, they no longer are interested in the traditional and conventional model of the education where you dump the information. You know, now the even though it is physically, we say that it is not good, like fast food. It is just taking up, it's spread throughout the globe. But when you come to the educational model, we need to look at how fast we can make these children to pick up the threats of the current requirements of the industry. I would like to call this as an fast food educational model that need to be adapted, and the students are really interested. When you look at it, what is the kind of courses they take in the electives, or when you offer interdisciplinary courses, or maybe sometimes you call them as hybrid courses. Most of the times I've seen the students, they shine well when they take up these courses, because they also have known what is the basic requirement of a particular discipline, as Dr. Mj Rahman rightly mentioned. And when the additional skills are imparted on the latest requirement, they are more keen to know, because when they go out of the institution, they are already, I mean, we call them as industry fit. Like the areas, when you talk about industry 4.0, whether you talk of big data analysis, or it is data analytics, or it may be the vertical integration or the horizontal integration, or let's say vice versa, or you talk of cloud computing, or you talk about IoT, or you talk about virtual reality or augmented reality, or the additive manufacturing. That's what I mean, you call it as a 3D printing. Either it is an automation, or you call it as an autonomous system. Today we would like to call this as an autonomous system. Simulation models. Then of course, lastly, when you talk of the cyber security, that is what it is picking up today. All these components are today getting integrated in any industrial environment. And this is what the students are really, I mean, seeking to do courses on these areas. But unfortunately, in the academics, what I see as a gap is that the faculty are not in a position to integrate. See, they are in a position to impart knowledge on these areas, but how to integrate them into the realistic model. That's where the gap that lies. Probably in the next component, I mean, I will also address this. I just only recall almost about 40 years back, I saw the assembly line of a car manufacturing unit in the Western country. When we looked at it, the robots have been working independently and then making the work. But still, if one point, if something is stuck, then somebody has to intervene and then stop rest of the robots in operation, from operation. But today, these systems have become autonomous systems. They communicate between themselves. And then if somewhere something is happening, then that signal is transferred to the other point. And how do we take this information to the student community? Unless otherwise, I experience as a faculty, I may not be able to translate this to my students. And that's where the entire crux of the problem today lies in our education system. We talk of fast food education, it's fine, but the fast food education, the chief or the chef should know how to make these components very well, to integrate them as rightly, I mean, you have shown it in the model, I mean, dashboard, or whether your panel or whatever it may be, all that, how to integrate and quickly how to, I mean, assemble them and make it as a tool or as an intelligent system. That is what it lies. The students are really, really, I mean, interested. Today, if you look at it, the innovation has become a core component in the education system. The students are very, very keen to do innovation. but only thing is they have to be given opportunity and the area where they need to do innovation. It all depends on both from the side of the industry and also from the faculty side. Okay, let me catch up with the next component for the rest of the thing, because time is running out.
Yeah.
Thank you so much.
Thank you, Dr. Kupuswamy. Excellent perspective. People will kind of remember you for this fast food educational model, the healthy fast food education model, which I think is like which is like kind of reality, where people need the result quickly. You don't want to be spending years and years learning something. You want the same model, and also your input about the information transfer versus skills. A lot of good input. Thank you, Dr. Kupuswamy. And I'd like to kind of switch gears to getting some input from Mr. Nitin Nair again on how does Siemens help in implementing Industry 4.0 solutions?
Yeah,
are there anything? Yeah, go ahead.
I mean, this round, maybe we can make it a little faster. No.
Okay, we'll make it like 3 minutes.
Yeah.
Okay. So, Mr. Nitin, if you could tell us a little bit about how you've been implementing 4.0 and what kind of things do you have to offer for academic institutions? Like, do you have like some training programs or kits or something that they could kind of work with you and get and move on? Your inputs would be great.
Thank you, Nano. So, see, as I was talking earlier, the most important topic for anybody who is implementing a digital transformation or a digital intervention is to first plan what we want to do, which digital interventions need to be done in the manufacturing shop floor. Once that is done, then we identify the core technologies, and first we test the core technologies not on the shop floor, but first we test them in the lab. Then we test them small on the shop floor before we scale them up. And I think that's also the methodology. Most of the people whom we work with are very, very comfortable with that, because they also see a clear progress, they see the results. And since what we are doing with Industry 4.0, many times also for the users is a first-time experience, it gives them a chance to kind of give a feedback, and we can jointly make a course correction. So that's for the first part of your question. And for the second part of the question, we work together with the colleges to create a center of excellence for the colleges, and which is again with the same methodology where we focus a lot on the core technologies and the pieces on how you can use these core technologies for industry-specific applications. So, if we are talking about an IoT technology, then for the industry it would be meaningful, because we know that, for example, the biscuit industry ends up burning 2 biscuits for every 10 biscuits that they produce. So if I can use the IoT with oven, both oven is a traditional technology, has existed for years. Now, if we can use the IoT connectivity and the data to control and see that my biscuits are not burning, and in every 10 biscuits, at least as a start, I'm down from burning 2 biscuits to burning 1 biscuit, then already we have made a 50% improvement in the right direction. So for the colleges, I would say it is these kind of what do you say, kits with which the students can play with real life examples of the industry is what is very, very important. Yeah. For example, smart grid. We talk about smart grid, and we talk about switching at very high voltage levels like 965 kV and so on. But a student in a lab could, even play at a low voltage and use the IoT technologies to do the switching at a very, very low voltage in a safe environment, and soil his hands and look at testing out the core technology pieces in the lab before putting it in the real world.
I think that makes a lot of sense. That's like a very good input. And thank you, Nitin, for your input on that. I'd like to kind of switch roles again and get into the little bit of input from the education team. I'd like to ask Mrs. Mjy Rahman on if she has some examples of some case study based approach for students to accelerate their learning. Mrs. Mjy, if you could give me some input in less than 3 minutes of anything, some just points.
Sure,
Thank
sir.
you.
I would like to say that yes, case study based studies are always beneficial for students, because just learning the things, knowing the things is not sufficient enough, as Nair sir rightly said, Nitin sir right now just said that they have to spoil their own hands and then they learn much better than, because they even get the chance to know the pain areas and the challenges to actually implement the technology which is known to them. So I would just give me a chance. I would like to share my one of the examples which we did in our Center of Industry 4.0, so that students can understand how can the baby steps can be taken towards the learning. Is my screen visible?
We can see your screen with the factory assessment.
Right.
It's
a remote product monitoring system with IIoT project. It's a joint venture of C4I4 Labs and Vishwakarma University, which we implemented in our workshop. Actually, we had a traditional lathe machine which we digitized with the help of students. Mainly students implemented it, of course, with the facilitation of C4I4 Labs and faculty. This is the traditional lathe machine which is available, and which we digitalized by adopting the digital scales on it and few of the sensors with the Simco IoT controller on this particular machine. And now this can maybe sense how many jobs we can produce on this machine, and how the life of lead screw that can be judged for the predictive and of course resulting in preventive maintenance point of view. So to give the idea to the students very well actually what is expected from the industry perspective, if we start taking few of the small steps, then also it will be very useful for them to go for the learning actually the industry perspective and industry point of view. Because many a times they feel that looking at the superficial things, they are quite great, but actually when they try doing it, start losing hopes very fast. One more, not exactly the case study base, but this is a factory assessment tool which is developed by C4I4 Labs, and our students did the assessment of few of the tier 2 industries around 25, and get a chance of shadowing maybe the production manager or such a high level authorities in the factory. And with the help of these tool, they did the assessment and come to know what exactly the Indian level is right now, where industries are lying in the era of whether they are level 2 or very few like Siemens are 3 and 4 level thinking of, but majority of the factories are level 2 or not even sometimes level 1 itself. So if we give them the case study based learning, then it becomes easy for them to get accustomed in actual scenario, and then they don't expect something which is in dreams or so.
Yeah.
So case study based approach is always better. Thank you so much.
Thank you so much, Ranmai, for sharing that real life case study, that lathe and everything else. I think you know, that's a very good example of, you know, a case study based approach. Thank you so much. We'd like to you know, go next to Mr. Rajesh Ray and get some input on how IBM helps their clients in implementing Industry 4.0 solutions.
Hi.
Rajesh?
Hi, can you hear me?
Yeah.
Okay. Thanks. So I think we had very good inputs already from Mr. From the panelists earlier. So as you know, IBM predominantly being an IT or information technology and consulting company, our major role is one part of it is definitely developing embedded systems. So that we have a specific focus which is on designing embedded systems. So typically people, companies come and, you know, they are trying to put integrated chips into this. They are trying to make their product smart, like, you know, and they are designing the embedded system is something where we do a lot of work. So that's one division of our stream. Second division where we implement Industry 4.0 is in shop floor, where we do a lot of work in terms of understanding and first trying to agree with business that what are the areas where they want to get benefits from. Like I was just telling that if you tell that I want higher manufacturing productivity, or I want my rejections in the shop floor to be reduced, or I want my machines did not be down, or, you know, as much uptime of the machine I can get. So we understand first those business drivers and then try to put solutions to make that happen. So typically, you know, it involves understanding the data layer from their ERP solutions, from their shop floor, what we traditionally call as MES systems, from their L1, L2 systems, and bringing that data, creating analytics on top of that, or creating predictive solutions on that so that it helps them to achieve those business KPIs, right? What I just talked about. Third is there is a team in IBM which works with IBM R&D to develop solutions which is on this next generation technologies, like, you know, on 3D prototyping and additive manufacturing. We are currently working with few clients where to develop solutions on that. We are also working with some car companies to develop technologies for autonomous cars. So these are more like research kind of work. It's not that these solutions are available in the mass scale, but these are more research kind of work, and, you know, we work with the client and co-develop the solution. And fourth kind of work which we do is in the automation space. So that's a space which is a little bit mixed area. So it is essentially involves industrial automation, it involves robotics, it involves computer integrated manufacturing and multiple technologies together, where essentially the focus is on automation. And here we started with Industry 4.0, but essentially, as you all know, that it is moving into the directions of other supply chain streams like logistics 4.0, procurement 4.0, etc. And they are trying to put more automation into place and how we can do more industrial automation into these processes. So these are predominantly the four stream where we work, and we have around 1,200 people in India now, and some people in other countries as well, who work on these four streams of Industry 4.0.
That's excellent, Rajesh. That's a very good input, and I think people, students could aspire to be the the next addition to your 1,200 team. I think that's good data for everybody. Thank you so much, Rajesh. I'd like to go back to Dr. Mj Rahman and ask him a little bit about a continuation of the previous question which we asked him. What kind of infrastructure is required for engineering institutes to learn 4.0? Like, do you need something new, or how have you been able to how do colleges work through this problem?
So as Professor Kuku pointed out, so we are having the curriculum, designing a new curriculum is not a problem. We are getting a lot of inputs from the industry, but we are also having the resources. It may be the online or on. The major problem is we have to train the faculty and they have to carry forward to the students inside the classroom and also the outside the classroom activities. The more than that, the hands-on training is very much needed for the students. I do agree, as Professor pointed out, by the students are very much interested in the projects. We have seen a lot of things at the Innova competition in Paris and the hackathon conducted by the MHRD. So the major point is the individual institution should have a common place that is called as a project lab. Some of the colleges are having, but it is a common place where we have to provide the workbenches, then the 3D printing machines, the press working tools, and then the microcontrollers, Arduino boards, so the sensors, so kind of things. So a student should form a committee, form a group, and they have to get into the lab and they have to do their own way, because a lot of things are available on the net and they are simply buying and they are demonstrating. It is not much useful. So they have to do all those things. So in this, at this point, we have to thankful to the Dr. Nanu sir, because our faculty members went there to Madurai, utilizing his labs, and he demonstrated very well. So that kind of facility should be implemented in all the institutions. Some of the institutions are having, but still we are not having much infrastructure. So a student can enter anytime 24/7. They can do their own way. They have to make their own products. Whether it is going to be successful or the failure, but he has to do everything. So the hands-on training on the latest technology, even the mini ERP packages or the workbenches by the Siemens or the IBM or IoT kits, these are all will be helpful for the students, so that they will be very much learn a lot of the nuances of to make there is a match the industry 4.0. Thank you.
Thank you, Dr. Jairam. It was, you know, I think we are at a stage where, you know, even mechanical engineers need to talk about controllers, Arduinos, you know, Raspberry Pis and everything else. And yes, it's no more, and I was so glad to hear you mention all those, you know, things being, you know, although your background is mechanical, I think those boundaries have gone away. And I think the leadership you have in talking about that is excellent. Thank you so much. So let's move on to the last question that I have for the industry panel, which goes to Atul. What are the prerequisites for implementing Industry 4.0, and is there a roadmap for such an implementation? What is your perspective, Atul? Please let us know.
Yeah, sure. Regarding the roadmap for implementation, I think Nirmay has helped my job a bit, because she has already explained about the factory assistance program, and that is the one which I worked with C4I4 to create that program. So there is a maturity model called Industry 4.0 maturity model that I have created for C4I4 labs, and it is in line with the software capability maturity model, which is more useful for the industries to find out how they can go ahead with the implementation of Industry 4.0. But coming back to the students and faculty, I would just like to share one slide or two slides, which basically tell what kind of a roadmap they can have. So just let me know if my
we can
slides
see
are
the
visible.
Leader in the 2020 Gartner Magic Quadrant.
Yeah.
Yeah, we are seeing
So
it.
are you able to see this?
So you have to select the PowerPoint. We are seeing, got it.
Yeah.
Got it?
Yeah.
Okay. So if we want to see the roadmap for Industry 4.0, you'll find that a lot of industries in India, at least, are not having the 3 pillars in place. So putting Industry 4.0 on top of no pillar in place is a dangerous proposition. Worldwide, the way it has happened is since 1980s, we had a lot of business applications in place which were computerized, like the ERP, supply chain, CRM systems, and so on. Then by 1995, we had IoT, IIoT, and a lot of data capture that started happening because of robotics coming into play. And by 2010, we had analytics and AI-based decision making. So these are the 3 basic pillars on which people can study. Even Rajesh had suggested this T kind of an approach. So earlier we had a phrase that you should be jack of all and master of none, or other way around. But today you need to be a jack of all and master of one, that I would say. So if you want to be in Industry 4.0, you have to be a jack of all these 3 pillars and master of at least one of those pillars. You may not be a master of all of them right now. The other way to look at it is look at it from a simple point of view. Forget about technology, forget about IT, software. Although most of the Industry 4.0 things are related to software and digitization, I would say look at this latencies. So you can look at reducing 4 latencies in any factory. The first is how long it takes for you to capture an event that occurs, because action cannot be taken unless you know what event occurred. The next part is you have to aggregate the data related to that event and action that you need to take. The third thing is to make a decision based on the data. And the last one is to implement the action itself based on what decision you have taken. So if you look at this from, again, a consultant point of view, to implement this, you have 4 C's to remember. First, how do you capture data? That is by IoT mostly. How do you collate the relevant data? How do you conclude or come to conclusions or decisions based on the data that you have created? And finally, how you control the machines at the shop floor again. Now here you'll find, as we have said, that a lot of other disciplines are required besides IT. Because although all this is IT driven, you still need mechanical engineering knowledge, civil engineering knowledge to understand what's happening and what insight you are collecting and how you are going to act on that insight. A programmer or a software specialist only knows how to do it, not what to do it. And I have been a mechanical engineer, industrial engineer, and then a software engineer, and then a consultant. And I realized that, yes, it's a good combination to be all these together. And then you realize that all these skills are really required, although I may not have all those skills.
Great.
Okay,
I
that's
think
all I
that,
would like to say.
That's actually, it's very good input. The slide that you have is actually like a little, I would say it's like a polished diamond, because it's just got the actual things that bring return on investment on, which we didn't really touch upon, for in implementation of any industrial IoT project. We need like a return on investment, and these 4 things that you've mentioned, bringing down all these, the times required for all these is like it's like a very golden slide, I think, which people should capture and keep. Thank you. So
and that's one more, which is basically combining all this together. So you start with the green, go to red, go to blue, and come back to the red. So that's the cycle, the 4 C's that we saw. Thank you.
Okay, excellent. Thank you. So the last question I'd like to ask Dr. Kuku Swami. How do you think the industry can help students to scale up and meet their expectations? I think Dr. Kuku Swami, if you could tell us a little bit about it. Thank you.
Okay, thank you for the question. I know the time is also running up, but I'll just finish it in a minute or 2. See, as you know that I'm just only always correlating the last 50 years of the industry and institute partnership. In the early years, it was not happening so well, but now in the last 20 or odd years, if you look at it, the industry is coming forward towards the institutions to share their requirements and also participate with the educational institution to build up the required human resource. Of course, there are a huge number of industries who also sponsors laboratories and things like that in the educational institutions. This kind of working together with an educational institution will definitely foster the process of developing the skilled manpower to meet the industry 4.0. As I told you in the beginning also, now we are looking at a fast food type of an education, where I think Mr. Atul also mentioned, I'm a mechanical engineer. I turned out to be a software and so on able to do. But now the education system itself, which we are thinking in terms of borderless. No, I mean question of specializing in civil engineering, mechanical engineering, and computer science, and we are expected to know A to Z. And under these categories, if you want the education institution to impart a knowledge to the younger generation, then first of all, the teachers have to be equipped with it. So that is what we have been trying to educate the teachers, or give the opportunity to the teachers to visit the industry, learn what is happening in the industry, and then come back and transfer it. In the same way, now almost I can say that we have to thank the COVID time. There are lots of industry people are coming forward to share their knowledge with the younger generation, because they need not physically travel, just sit in their office, spend 1 hour and talk to the students. I think this kind of knowledge sharing from the industrial side, and also giving opportunity for both the faculty and the students to go to the industry. I mean, get the, see, they may not be able to provide all the facilities in the industry and the time to work, but they can give the problems. The students can take the problems and come back to their education institution and try to work, so that they'll be able to practice what is the reality that exists in the industry. Once if that happens, then all our products, when they go out of the institution, then we can call them as industry ready. Because somebody also mentioned that not many graduates are industry ready, but if you want to make them industry ready, I think the collaboration, what it is happening to a certain extent now, it should we should scale it up further, so that a large number of education institutions get the benefit from the industries. Of course, the industry is also having certain limitations, but still, for the development of the country, we are talking of today sharing economy. The economy is shared. I mean, particularly the 4.0 also talks about it. So the economy, when you want to share, then it has to be from the education sector to the industry, and then industry to the education sector. If it happens, then the whole thing will be developed further. Because there is also a article that I have seen, what you prepare our children in the school days. I mean, about nearly 70% of the children may not even know what is going to be the real situation or the practical requirement when they are going to graduate out of the educational institutions, when they grow, I mean, to the age of 20 or 21, when they graduate. Because the technology is changing every day. We don't know in another 20 years how it will be, and how to prepare them. At least prepare them for today, they can fine tune it for tomorrow. That's what I look at it. And the industry has to open up their doors. It's not a question of secrecy or stealing something and all that, but there should be a mutual trust between the industry and the educational institution, and they have to work together hand in hand. Then I think our economy will shoot up like anything. That's what. Thank you so much for the opportunity.
Yeah, thank you, Dr. Kuppaswamy. That was excellent input. Thank you so much for bringing us up to date with your thoughts. Excellent. So I think, Bharani?
Yeah, yes, Nanu. So we have a couple of questions actually received from the audience.
Okay.
Interesting question came that during the session is, if all the electrical and electronic components are going to be digitally connected, how can we secure the access to those equipments? That's the question that was raised by one of our audience. Nanu, do you want to answer that?
Actually, I'm panelist to answer that, but that is a very, very important question, because we've been building things without thinking about security. Security needs to be built up from the base, from the silicon, right from boot up. See, right now, all the Android phones we run, we don't know what kind of Chinese stuff runs on it. Same thing with the Arduinos, with everything else. I don't think anybody in the world has a clue as to what all things run on it, and when your data is going out. And even the light bulb that I have, which I showed you, The one which I was using in the US, it used to make a connection to a server in China every time I turn the light on. So security is like a very, very important thing. And we don't want, things like what happened in Iran and Iraq, where, a virus could turn on these nuclear reactors, those nuclear centrifuges. So there are lots of things there. I think I'll ask Mr. Rajesh to talk a little bit about it, since, maybe he has some thing from the IBM perspective on how they handle this.
Yes, I think thanks, very relevant question. And as we all know that more and more data is moving into cloud. Whatever you are using on daily basis, say whatever mails you are using on Google or Yahoo, or whenever going to Facebook, to WhatsApp, for everything practically you don't know where the data resides, and there is a huge security issue. And that's why security and cyber security itself is becoming a big topic, and is a big component of Industry 4.0 as such. And I think that's going to become more and more important as more and more data is lying outside your premises. And whatever you do, starting from your mobile phone to whatever you do within the organization, and that's becoming a big topic, and that's a subject in itself. So to answer in one line, security and cyber security is the component of Industry 4.0, which is a big component which is supposed to handle this part of it. And hopefully that technology is also growing very fast, and they can handle those challenges.
Excellent. Thank you, Rajesh. Bharani?
Yes. There are a few questions which talks about, in general, how to become an industrialist and things like that. I think we will skip that because it's not our focus. Maybe we can answer one question. The student asking, how can we make the students to become an industrialist from the lab scale experience? How practical it is, or what kind of transformation is required? That's the question.
Okay, I think I'll give my input and then get one of the panelists also. So I think there's a big difference between what happens in a lab to what happens as a product. There's a big gap between getting something working with wires and a breadboard in the lab, turning on a light bulb in the lab, versus making a real light bulb that works in commercial environment. Two different things, and that's where this the entrepreneurial skills come in. So maybe if Atul can talk a little bit about it, since he's got like a little wide experience in all areas. If you talk us on how to bridge the gap between the lab to the commercial world.
Yeah, sure, Nandan. One thing I would suggest for these students who want to be industrialists is, from the lab model, there's something known as a lean canvas model. So the lean canvas model is the model used by many entrepreneurs, which gives you 9 or 10 dimensions of how your product can be actually commercialized. And I definitely feel that the other things that are required to be taught in engineering colleges, which is completely missing, is the finance part of it, the sales and marketing part of it, and the consulting part of it, because all these skills are required if you want to really set up a company.
Excellent.
Besides the legal and other issues, but at least these skills are required, so you need to be quite savvy at this.
So from your perspective, Atul,
can I add a point?
Yeah, go ahead.
Yeah, I think it's a very relevant question, because many of my students also asked the same thing in the early years. As Atul mentioned, we really miss out these components in our education system, particularly the students, particularly when they do engineering. They don't know what commerce is, and then what is the taxation, and what economy, and the business tactics, marketing, and things like that. Everybody thinks it's only an MBA, and when you do your management studies, all that you have to do. But the moment you think that you would like to become an entrepreneur, I think the first thing is, you should know how a business works. And if the business model is not known to them, then they can never become an industrialist. So that's why I suggest to most of the students, at least get an industry experience for 4 to 5 years, then you think of starting an industry. Even I remember having run a course on a bridge course wherein you make these engineers to be partly a manager, partly a economist, partly accountant and things like that. Once if you know this, then you can fit to start an industry. This is what it is missing in our education system. We need to integrate.
Yeah,
Yeah,
I think
sir,
it makes a lot of sense.
I would like to add one more point here that I was with IBM for a long time and I was into training for business consulting as well. I was a trainer. And the biggest challenge IBM had in 2008 because of the Lehman crisis was that they wanted to expand business. The bigger countries had no business to offer and only the developing countries, so-called, or the third world countries had a lot of business. And they wanted all the IBM India team to suddenly start consulting. So that's why they came up with a great training course on how a developer can become a consultant. And I was training people on that. So I think there's a very structured way for engineers also to suddenly become consultants. Although there are very few such courses available. And the big consulting companies have those skills, but they don't apparently take engineers or take trainers. They take
Yeah,
to get them there.
I think it's a very good input. You know, I always tell the people who come to our lab that building the product is like 20-30% of your problem. Making money out of it is 70 to 80% of your problem. You know,
true.
And the ratios could change a little bit based on the person.
So Nano, allow me to add something, Nitin here.
Go ahead.
So my message to the students is you need not focus on the topics of building building up the business. Please focus on solving the core technology problem. There are several platforms like TIE Foundation and so on, where you can enroll yourself. And a lot of people from the industry, me, myself, and a lot of companies, we regularly meet every quarter for this TIE Foundation meeting, where students with brilliant ideas come up and they talk about their ideas and what they have done and achieved in the lab or on the field. And then we adopt these ideas to take them forward as a business, or if somebody wants to be an entrepreneur, we are looking at bringing the required resources to them. So there are enough platforms like this. Please, and you make a use of these platforms is my message to the students.
Excellent. I think one more thing to add is, anybody aspiring to build a product, I think from day one, when you start thinking about the idea, you should have your customer, you should be working with your customer in hand, which, falls in line with this lean principle where you actually, even if you build a breadboard with the light burning, you need to show it to your customer and make sure that that guy is willing to use it and pay for it, and then move to the next stage. So working with your customer is like one of the key things. Varuni?
Thanks, Nano. I think we ran out of time. So May, you can conclude your discussions.
So I think it's been an excellent panel discussion. A lot of very good distilled input. I think to get all this data that we've got from our 6 panelists, if you are kind of trying to get all this data all by yourself, it will take you at least 2-3 months to get the input that each one of them has distilled. I have a whole page of information, right from fast food education model to, business transformation specialists, solution architects, platform specialists. There's so much good input. I'd like to kind of summarize by talking about the opportunities that lay ahead. So for students, maybe for students, for people aspiring to get into this field, I would strongly suggest, one is going the entrepreneurial route where you kind of build your own product. The second one is working in a particular company that is into manufacturing and using your skills to kind of enable new avenues for the particular company. So if you're working in a company that manufactures, electric motors, with the skills that a student has, you could augment the skills of the enterprise by adding value and talking about the opportunities that can be done with it. And then as far as the staff from colleges go, we have opportunities to work with Siemens, IBM, look at their career opportunities and map them to what students could, get into. And for the others who were involved in the call, a lot of input as to how this transformation is changing the world. We need basically people to understand the different times that information is flowing. So now we did hear about video and image processing and a few things that in a little bit. All the data has to be packaged and sent in a more intelligent form to services on the cloud and elsewhere to make sense out of it. So we need to be a little more, we need technologies to compress data into intelligent forms of interpretable data that can be sent across. So I think from my perspective, it's been like a great time to be talking to the 6 panelists and the wonderful questions from the audience. And as I said, there is a lot of input from everywhere. And, I was talking about Atul's polished diamond. There were actually several polished diamonds from different parts. So thank you all for the panelists for all your inputs. And thank you, Barney, for putting this wonderful program in place. Thank you, CNC. Thank you, the PALS team, and everybody else who's been together here.
Thank you. Thank you. CNC, you want to have a word?
Yeah. Just a quick thing. I introduced all the panels and the moderator kept it brief. And when I introduced Nanu, I said Nanu has got a mini lab. No wonder he's sitting in the lab, and he vindicated my words by demonstrating all the appliances in his lab. Thanks, Nanu. No wonder President Obama awarded a presidential award for you in 2013 for EdTech initiative. Just for the information of all those years, Nanu relocated to Madurai in South India after spending 30 years in Boston and San Francisco. Wonderful session. I wanted to keep this part of your introduction to the end, Nanu. I wanted people to taste your session and then hear about it. Thank you. Wonderful. Barney, if you all
thank you,
also
CNC. Actually,
yeah.
CNC, actually, today I'm at home. So, sometime when I'm at the lab, and have like if people are interested in visiting, they can sit and see all the much more cooler things. So thank you so much for that intro, which was like a hidden, quant, which not many people know. Thank you.
Thank you.
And one more thing, Barani, actually, Mrunmai mentioned about taking baby step in Vishwakarma University when she showed late. I want to really share a baby step taken my granddaughter, in the industrial automation. She's just 2 years old. She really made Alexa device understand her baby language, by asking it to play Baba Black Sheep in whichever way language she says, Alexa understands. And even it's renamed Alexa as Alaya, So, I think that was a good baby step, and I thought of sharing this baby step taken by my granddaughter.
Fantastic.
Over to you, Barney.
Yeah, thank you. Okay, finally to the vote of thanks. I first like to thank Atul Marathe. He was the one who initiated the spark. Why not we conduct the Industry 4.0 as a session? So wonderful idea, sir. I think we got a wealth of information. The students must have really had a very enjoyable session. There are a lot of things were shared. Thanks to Nano. Nano, you made us look like we were in the lab of Dr. Vasigaran of Rajinikanth movie. We have to, hopefully next time you will see a robot there in your lab. I also would like to thank our industry partners, Nitin, Rajesh, who had contributed their time, I mean, valuable time. I'm sure they are under the busy schedule. They have taken time to come and give their experience. Thank you very much, Rajesh and Nitin. I would like to thank Professor Kuku, Professor Mj Rahman, and Mrs. Mj Rahman for all your efforts and giving wonderful insight into what's happening in the education sector. And I'd also like to thank some of people who've taken time, Mr. Ananta Oliviti and Shyam Kumar from the Nasarathat Engineering Institute, Guntur. So thank you, sir, for taking time and attending the session. And also thank you, Vipin, for taking time to attend this session. Thank you very much, all of you. Okay, we'll meet next time then. Thank you.
Thank you.
Thank you, Barney. Wonderful. Thank you all. Thank you very much.
The feedback form has been posted in the chat box. Kindly give your feedback before you log off. Thank you.
Thank you, PBM, for staying so late.
Thank you, CNC. And it was such a wonderful session that I was glued to my iPad for the last 2 hours.
Okay.
Really a fabulous session. Well done, Nanu. Well done, Bharani. Well done, all the panel members.
Excellent.
And each one spoke with so much of simplicity and focus that I'm sure the audience who wanted to know about Industry 4.0 and how they could approach it, they must have gone back with a wealth of knowledge, no doubt at all. It was a fabulous session.
It's nice to have Vipin also. Vipin, would you like to say anything? We can ask our PMO to unmute you for a few minutes. Can you unmute Vipin? Robin?
Hello, can you listen? Yeah, I've been
we can hear.
I've been working with Industry 4 solutions to industry, basically to plastic units. And the company with which we are associated, we have already given solution to some 3,000 injection molding machines. We have converted them into Industry 4 relevant. Like the data is collected from sensors, and then the predictive analysis, the production monitoring and energy monitoring, everything is done. So I mean, the biggest first step is to convince people, because everybody is so complacent. He says, I'm doing everything is fine, I don't need your help at all. But then we have to slowly convince them, and we are like yesterday I have succeeded in convincing one molder who has got 20 molding machines, and he is ready with the solution which the company is offering. So I'm in this field, and I like to learn from others also continuously.
Excellent. Thank you so much.
Great,
we can't see you, but I think you probably can turn on the camera for a minute or so.
If you can see me, okay. I think you can see me now.
Yes.
Yes. So now I was myself a plastic molder. I'm from IIT Bombay, and basically I'm working with ASIA Limited. It's my initial years before it became ABB. And then I started my own molding unit. I was a ancillary unit to Panasonic. And later on, I disbanded that, and now I'm basically now a sort of a consultant, domain expert to a software company which deals with Industry 4. So I have enough experience of entrepreneurship also. So when the right moment comes, I'll talk about that also.
Great.
Welcome to PAL's family, Mr. Vipin. I'm sure that with all your experience, at some point or other in the course of your journey with PALS, we'll be using you as a resource for some program or the other.
Yeah, thanks.
And also we look forward to your ideas about how we can conceptualize and develop more programs which are industry-centric and actually help us to bring the academia industry gap, to shorten the gap, in short.
Sure. I'll be glad to. I mean, that's what keeps me alive. Like I would like to share my knowledge and see that people don't make some mistakes which easily done, so they learn from somebody else's mistake. Okay.
Thank you so much.
Very good. Okay. Thanks a lot. Have a nice weekend, all of you.
Thank you.
Thank you, Dr. Kupuswamy, sir, for joining us today.
Thank you. Thank you.
Okay, can we close the session? Yeah, unless you want to take a group picture, Bharani, I thought that's what I thought. You know, you may be coming up with the idea of taking a group picture. I'm not sure this too late. Bharani, what's the next step?
Barney is already left CNC.
Yeah, I think we just sign off now.
Yeah, we can
Okay,
sign
I
off.
think Bharani is left. Okay,
Yeah,
great. Thank you so much.
Thank you. Thank you.
Thank
all.
you.
Goodbye.
Thank you.
Bye.
Yeah, thanks a lot.
Thank you, sir.
Thank you all.
Thank you, ma'am. Thank you.